You might want to try this one. Okay, so here with this integral, and it also says, had to struggle a lot to get this one. Let's have a look. We have the integral of 2 plus square root of x over the parentheses with x plus square root of x plus 1 squared. So I think let's just do something that we would like natural to do, right? That's the u-substitution because it looks like a u-sub question, right? We make this equal the u, and let's just try it. U is x plus square root of x plus 1, and do the usual business. Du is equal to 1 plus the derivative that is 1 over 2 square root of x, and the derivative that is 0. Okay, and perhaps if you want to isolate the dx, sure thing. Okay, so this is 2 square root of x, and then top and bottom by 2 square root of x, and then plus 1. And multiply by the reciprocal, so dx is equal to 2 square root of x over 2 square root of x plus 1 du. And if we put this to the u world, right, take this to the u world, we are going to get the integral of 2 plus square root of x. That, okay, we have square root of x here. It's not going to be so easy to solve for square root of x in terms of u. It's possible, but we will have to use the quadratic formula maybe, and I don't think it's going to be that easy. In addition, on the bottom here we have the u square, and the dx is that we have the 2 square root of x over 2 square root of x plus 1 du. Yeah, it looks like we have to have the square root of x somehow, right? So again, if you would like to try, you can go ahead and go for it, because that equation is the same as square root of x squared plus square root of x to the first power plus 1 equals u, and we can just subtract u to both sides, from both sides, and you can see that we have a quadratic equation in terms of square root of x. So the a will be 1, and then the b is 1, and c is this, and use the quadratic formula, and good luck. I don't think it's going to be very easy. I don't even know if it's possible, and all I know is that I don't want to continue with this method. So how exactly can we do this though? I think right now I would just have to say, to solve this integral, the method I'm going to use is called solve it by experience. I think that's just pretty much how it is. Sometimes when you do a lot of this, when you have done a lot of this kind of things before, then maybe you just start to try something new or try something slightly unusual. And let's go ahead and try it. The thing that we are going to do is, on the inside here, I'm going to factor stuff out. I'm going to factor out the x. Have a look. We have the integral 2 plus square root of x over, I'm going to have the x, factor it out, so we will have just 1 here. Square root of x, we factor out the x. Just think about square root of x divided by x. Then we get plus 1 over square root of x. Imagine if you multiply this and that, x over square root of x, you get square root of x. And then we have the 1 factoring the x. Again, just think about it as dividing by that. Okay, so that's what we have. And of course, we still have the square. I'm going to put a square here and a square here and the dx. And again, you might be wondering, like, how did I know to do this? Because I have done similar problems before, you guys can check out my old video. If I can find it, I will show you guys a screenshot here, and the link will also be in the description. All right. And how can this be continued from here though? I'm going to bring this up. So this is going to be the integral 2 over x squared plus this is square root of x over x squared. And on the bottom, I'll just keep this. And let me write this in the power form. So we will have 1 plus x to the negative 1/2. And this is x to the negative 1 and square that. Now, I'm also do the same right here. This is the integral 2x to the negative 2. This is 1/2 minus 2 is negative 3/2. So that's plus x to the negative 3 over 2. I think some of you guys see this already, huh? Yeah, 1 plus x to the negative 1/2 x to the negative 1 squared dx. If you differentiate 1, it's just 0, so it doesn't matter. If you differentiate this, we get that, huh? Of course, we have some constant, but that doesn't matter that much. If we differentiate this, we get the x to the negative 2. Yes. So that's the key right here for this question. And now let's just go ahead and do it. I am going to continue right here. U is equal to the inside 1 plus x to the negative 1/2 plus x to the negative 1. du is equal to that's 0, and we have negative 1/2. Subtract 1, we get negative 3/2. And then bring the negative 1 to the front, so it's minus, and x to the negative 2. Okay, dx. And if you can look at it a little bit, okay, we have a 2 right here. If you would like, you can also factor that out to make it clean. If you would like, but it's not necessary, depends on how you want to work this out. As long as we have the function part, that's all it matters. So let's see how do I want to continue to show you guys the rest. Okay, I'm going to just make a note right here real quick. I'm going to factor out the 2 to the front, and then we have x to the negative 2, and then this right here will be plus 1/2 x to the negative 3/2 over the same denominator. Okay, I think that is much better. I know we have the negative, so perhaps I will just multiply the negative on the outside, and then multiply the negative here, and then multiply the negative here. Much better. So as you can see, all this right here, right now, all that stuff is exactly what we have for the du. So we will have negative 2 all the way in the front, integrating. So all that is du, we have the negative here already, and we just have 1 over the inside is the u, square that, and we have the du on the side. Yeah, just like that. And of course, work this out is u to the negative 2. So add 1 to the power is negative 1 and divided by the new power, and that will give us a positive 2, u to the negative 1, which is 1 over u. U is that, and I'm just going to write it down like this. So 2 on the top over u, which is all that, so 1 plus x to the negative 1/2 plus x to the negative 1, and then what that? Plus c. And of course, feel free to write this in the fraction form or the radical form. Yep, doesn't really matter that much, but that will do it. Then you guys can also try the other 2 questions I have for you guys too. So that's it.